Good afternoon, everyone. This is Larry Stevens with the Museum of Northern Arizona in Flagstaff. And in our continuing series on Grand Canyon, today I'd like to talk to you about the effects of Glen Canyon Dam on the Colorado River ecosystem in Grand Canyon. And we'll step through 3 dozen slides here about the effects of the dam on the Colorado River ecosystem. First, just to reiterate a little bit of our message from last time, to remind us all that the Museum of Northern Arizona has a 91-year history of research in Grand Canyon, with eminent scientists such as Walter McDougall, Eddie McKee, and more recently Steve Carruthers, working on the details of how the river and the canyon ecosystem function, what their biodiversity is, and how to better apply good policy and scientific decision making to that ecosystem. As we stand on the rim of Grand Canyon, we can look down there, can't really see the river very much. You know, any single view of Grand Canyon is only about 5% of the whole landscape. So these are, as spectacular as the views are, we know there's a lot more mystery down there than we can see from the rim. But what is down there? There's an entire universe of wonderful ecosystems, species, processes going on, and this world below the rim is the realm of the Colorado River in Grand Canyon, the river that cut Grand Canyon and has transported about 750,000 cubic kilometers of the Earth's crust through this drainage network. So we'll look at that today. In terms of what the river is about and how it's managed. Now, to step this into the realm of geography a little bit, because Grand Canyon is not the top of the Colorado River by any means. It's kind of in the middle of the drainage. The upper Colorado River basin extends all the way up to Wyoming, and then downstream all the way across the U.S.-Mexico border to the Sea of Cortez. So this is a landscape with a lot of diversity to it, tremendous elevation range, more than 4 kilometers of elevation change, and Grand Canyon lies about in the middle of that course. Grand Canyon makes up about 2,000 square miles. The river through Grand Canyon from Lee's Ferry to Lake Mead is about 280 miles long. This is one of the world's most prominent large deep canyons, certainly one of the best known large deep canyons, ecologically, politically, and scientifically. In pre-dam times, so before 1929, the Colorado River was a wild animal. It flowed in an incredibly erratic way all the way through its course past the city of Yuma and down into the Sea of Cortez. And in the late 19th century, it was viewed as a seaport. Boats were able to navigate up the Colorado River from the Sea of Cortez, and that made Arizona. It gave Arizona a seaport. However, the flows were so erratic that it was very difficult to manage that kind of seaport possibility there. Mining goods, mining ore and whatnot were taken downstream, and various commodities were brought upstream by steamboats. But really, the flooding of the river really kept a lot of the sea traffic out. So, a group of politicians got together and decided that it would be best to sacrifice the seaport function and turn the Colorado River into a water supply system, mostly for irrigation at the time. But these were the days early in the 20th century when water law policy was being decided. So the Colorado River Compact of 1922 was established the boundaries of the river corridor. It created an upper Colorado River basin and a lower Colorado River basin, shown there on the right side of the screen. And then it granted overestimated the amount of water, but it divided the amount of water of the Colorado River up into 2 equal portions. The upper basin and the lower basin each received 7.5 million acre feet of water per year. The upper basin is Wyoming, Colorado, Utah, and New Mexico, with a tiny fraction of Arizona, oddly, in the upper basin. And the lower basin allotment was for California, Arizona, and Nevada. The lion's share of the water of the Colorado River goes to the states of Colorado and to California. Arizona is third in the list there. Nevada gets relatively little from in this arrangement. Mexico also, through another treaty later on, receives 1.5 million acre-feet per year. We'll talk about these numbers in a little bit. But this 1922 compact set the stage for how water was to be managed in the Colorado River Basin. Upper basin, lower basin, division of the states, etc. That was an important decision because it set the stage for all kinds of politics and political actions. In 1923, the U.S. Geological Survey launched an expedition through the entire river basin, and especially in Grand Canyon, and they mapped, for the first time, the Colorado River. The river had been explored by John Wesley Powell and Robert Brewster Stanton, but really never approached as a geologic map in a geologic mapping context. So they ran an expedition in August through the river corridor, took many photographs that have been quite useful in terms of understanding change in the ecosystem. Quite a remarkable expedition to accomplish. Now, in 1956, another law was passed, the Colorado River Storage Project Act, or CRSP it's called, and this allowed the upper basin to develop its water supplies. And to do so, the states and the Bureau of Reclamation, which is the leading water agency in the upper basin and much of the lower basin, moved forward with plans to build 7 or more large federal dams. Up in Wyoming, the Fontanelle and Flaming Gorge dams. In Colorado, the Morrow Point, Blue Mesa, Crystal dams, Navajo Dam on the San Juan River, and at the very bottom of the upper basin, near Lee's Ferry, Glen Canyon Dam. The boundaries of the upper and lower basin is a place called Lee Ferry, about a mile downstream from Lee's Ferry. So of these, Glen Canyon Dam was constructed from 1957 to 64, and it's the largest CRSP dam. It's the second largest reservoir in the 48 states. It produces a fair amount of hydroelectric power, that is served to more than 200 utility companies, and with the water storage and hydroelectric power production, it serves about 40 million people in the Southwest. The Colorado River, of course, is the main water supply for the Southwest. The dam is a gravity dam, 700 feet tall. As I said, the construction phase lasted from 1956 to 1963. Power production began in 1964, produces 1.32 megawatts of hydroelectric power when it's at full stage and has maximum head on the reservoir. The dam was presented to the public by Lady Bird Johnson in 1963, and in a big ceremony. And the dam is, of course, a technological wonder. It's such a complicated, big structure, 10 million cubic yards of concrete, etc. So what we're approaching here today, though, is what are the effects of Glen Canyon Dam on the Colorado River and the society associated with it. So what are the socio-ecological effects of the dam? And the dam, this is a construction project conducted 75 years ago. It was in a previous generation. The values that gave birth to it are not necessarily those of today, and the dam has many trade-offs associated with it. Nonetheless, it's producing a lot of power and serving as a water supply. As it serves as storage of 1/2 of the Southwest water supply. So it's a pretty important feature. Looking at what these trade-offs are, there are upstream trade-offs and downstream trade-offs. The upstream trade-offs are we lost Glen Canyon, which would have been a national park in its own right, 180 miles of absolutely fantastic sandstone landscape that we lost. But oddly, the loss of Glen Canyon initiated and inspired environmentalism in the United States. This was really the birth of public environmentalism in the United States. So that's a trade-off that's pretty interesting to try to consider sociologically. Downstream impacts of the dam include flow regulation, reduction in sediment transport, meaning and water clarity, and cold constant temperatures for the river. I'll talk about each of those in succession down below. Another big effect of the dam has been on changing river management policy, not only in Glen Canyon, not only in the Colorado River Basin, but throughout the world. Dams are like many forms of human disturbance of the landscape. What humans are really good at is increasing the predictability of the ecosystems that we manage, and also simplifying those. And so those patterns of increasing the predictability of the ecosystem, reducing flood flows, for example, and simplifying the ecosystem are things that we're looking at in terms of Glen Canyon Dam's effects. So kind of interesting that we do those with all kinds of things. Forest management, think about prairie management for agriculture, putting in seawalls along coastal lines to protect our shorelines. In each case, we're trying to increase the predictability, reduce the amount of disturbance that those ecosystems are operating under, and simplify them. That seems to work out best for human society. It doesn't necessarily work out too well for the ecological systems associated with those in those settings. Among the other net effects of the dam have been that the dam decoupled the river from climate. We have, again, a couple of years of water storage in the reservoir, Lake Powell Reservoir, upstream from the dam, and that reduces the influence of climate really on the downstream river. As I said, we lost the wilderness, but oddly, with the clear cold water, we've increased productivity, riparian habitat development, created a very very important trout fishery, and stabilized the shoreline, as well as other habitats along the river, and the economic stability of the landscape. The dam produces about $30 million of revenue in hydroelectric power. Again, it serves upwards of 40 million people, including the water supplies that are managed here. And the recreational industries associated with downstream river running, with fisheries and whatnot, amounts to about $30 million, up until this year when a lot of that was interrupted by the pandemic. So let's go through these trade-offs one at a time. The loss of Glen Canyon, again, was a tremendous loss to our natural heritage in the Southwest. And oddly, it was the birth of environmental activism in the United States. And these two gentlemen, David Brower and Martin Litton, both part of the Sierra Club, were wakened to the issues of dam environmental impacts, and subsequently prevented the construction of more Colorado River dams in Grand Canyon through the 1960s and 1970s. These two are real environmental heroes for a lot of people, myself included. Okay, the second trade-off has to do with flow regulation. Pre-dam flow variation at Lee's Ferry is one of the leading gauges at the upstream end of Grand Canyon, provides a depiction of how flow changed from low flows and the minimum flows, average minimum flows in pre-dam time, the mean flows in pre-dam time shown here in blue, and the extreme high flow events that came through the system shown here in green. Now, these are measured in cubic feet per second or cubic meters per second. Nobody really understands what those are, so I translated this into the mean number of bull elephants per second running by Lee's Ferry. And on average, about 50 bull elephants race past Lee's Ferry every second. That's the mean average flow in both pre-dam and post-dam time. But as in pre-dam time, we would have as many as about 750 bull elephants racing by per second. This is bull elephants as a measure of water. A bull elephant weighs about 7 tons, so doing the calculations on these, the graph here is in the number of elephants per second running by Lee's Ferry. So one thing you can see is that the elephant races were kind of not very dramatic when it comes to the minimum flows that came by. In some of the years in the 30s, for example, low flows only reached a rate of about 90 elephants per second. However, the high flow events were highly erratic. So charging stampeding herds of elephants coming through here, ranging from maybe 400 up to 750 as the peak springtime flow came through. And then summer monsoon activity could sometimes stimulate really dramatic increases in flow. During that 1923 US Geological Survey, there were about 400 bull elephants running through the river, coming through a flood that came through the Little Colorado River. So very erratic summertime flows. And in post-dam time, that flow regime has changed really dramatically. Here's a portrait of the 1957 flood, which is the last 10-year flood we had in Grand Canyon before the dam. And here is the kind of the daily flow pattern. Weekend fluctuations, weekend drops of flow, but very consistent flows at about the level of 500 cubic meters per second or so. And these details are even more explicit when the more you zoom in on these kind of graphs, you can see that the daily flows are really very stable. These are policy decisions about how much water to release from Glen Canyon Dam. The tributaries in Grand Canyon don't really provide much additional flow, so this is really pretty much what flows through Grand Canyon. We manage planned floods in the system. This is an example of a planned flood in 2016 as a spike event. But notice that it's only coming up to a level of let's see if we can get back to the elephants there, a level of about 400 elephants, far lower than the maximum pre-dam flow. So these most of the daily operations are about daily flow fluctuations. There is a little bit of seasonality, high flows in the winter, high flows in the summer, but really very little variation in flow. So we've taken this highly flood-prone ecosystem and transformed it into a very stabilized flow system. Some of our understanding of the effect of Glen Canyon Dam also have to do with a more regional understanding of what's going on in the Colorado River Basin. Under climate change, snowpack is decreasing in the Rocky Mountains, and the Colorado River has long been looked at as a snowpack, as a snowmelt economy river system. However, in recent years, we've been able to do studies and try to learn better that about groundwater contributions, and it now appears that more than half of the river's flow is derived from groundwater, with almost 30,000 springs known in the Colorado River Basin overall. And these springs are rich and very diverse in geomorphology and geochemistry and biodiversity, huge cultural values to Native American tribes, and rather enormous but unrecognized economic values for the Anglo world and the dominant culture. So if you want to find out more about this, you can visit the Museum of Northern Arizona Spring Stewardship Institute website, and our next presentation will be about the springs of the Colorado River Basin. So growing realization that groundwater is a major player in this river now, and the Colorado River is transitioning from a snowmelt river to a groundwater dominated system. Now, the third trade-off has to do with reduction of sediment transport. Less sand flows through Grand Canyon because of the dam. It's captured by the reservoir. Sand settles out in the still waters at the upper end of Lake Powell. In pre-dam time, this was an incredibly thick river, too thin to plow, but too thick to drink, was the saying that they had with it. Again, a highly seasonal flow pattern of sediment moving through. The more flow you have, the more sediment. There's a power function in how water carries sediment. So low flows carry very little sediment, but when flood flows start to pick up, it's really a dramatic increase in the amount of sediment. So in pre-dam time, about 60 million metric tons of sediment per year. What does that mean? About 8.6 million bull elephants worth of sediment passing through the river corridor each year. This means a 5-ton dump truck at the rate of one dump truck every 2.3 seconds moving through the system carrying mud in it, or one elephant every 3.7 seconds. So just imagine a continuous stream of elephants flowing by, walking by, stampeding by Lee's Ferry each year, carrying the sediment. So that trade-off is a big deal because without that sediment input, beaches erode, cultural sites erode, the shoreline changes from sand to rock, and those are all big changes for the river ecosystem, changing habitat for fish and everything else, and also the turbidity of the water. And so without the sediment coming through, the water has become clear for the first time. The fourth transition in the river ecosystem has been uniformly cold water coming out of Glen Canyon Dam. The water is released rather deep in the reservoir through the 8 bend stalks, and therefore it always remains pretty cold. In pre-dam time, the river froze over, so going from freezing or slightly below freezing with ice across the river at Lee's Ferry, people able to drive their wagons across Lee's Ferry on the ice during the winter months, to now to summertime highs in July, approaching 90 degrees Fahrenheit at Lee's Ferry. We don't know what the temperature was downstream, but starting at Lee's Ferry, especially if the flow is low at a temperature of 90 degrees, the water could well have reached 100 degrees by the time it passed all the way through Glen Canyon into what's now Lake Mead. 100-degree Fahrenheit water passing through the landscape. Water temperature is really important because it provides cues for the life history of many aquatic organisms, fish, invertebrates, etc. And so that range of temperatures was probably quite important to the life in the pre-dam river. In post-dam time, the river ranges from 47 to 50 degrees Fahrenheit, ranging in years where Lake Powell is quite low to up to 61 degrees. But there's very little annual variation, so there's no more thermal cues for aquatic life. Here's a graph of what that temperature transition was like from the late 1940s through the early part of the 2000s. Very wide-ranging temperature every year until about 1965 or so, when the effects of the dam began to be reflected in temperature, and then proceeding to a pretty stable constant temperature of about 8 to 10 degrees Fahrenheit, Celsius, meaning about 48 to 56 degrees Fahrenheit throughout the year. So big transition in temperature there. The last trade-off that I want to talk to you about is policy and management. Well, in pre-dam time, of course, there wasn't much management. There was a lot of groaning about and complaints about these unpredictable floods moving through and wreaking havoc on the agricultural lands that were being established in the lower Colorado River Basin. But since the time of the dam, much policy and management has taken place, and a lot of it's changed within the last 30 years. Before 1990, from 1965 to 1990, it was pretty much just open season on flow variation to produce as much water and produce as much hydrologic energy as possible. Beginning in 1991, flows were dampened down to conserve environmental resources, and eventually that process led to what's called the Glen Canyon Dam Adaptive Management Program, where a complex group of stakeholders, 27 stakeholders, supported by their technicians, provide information to the Secretary of the Interior about how to manage Glen Canyon Dam. That group is also fed information by the US Geological Survey, independent science advisory panel, and that group provides information to the Secretary of the Interior, who's really the water manager for the entire Colorado River in one way or another. That group's information is also weighed by the Secretary of the Interior in terms of the operating plans, and as another federal advisory committee that provides the Secretary with information about what the needs are in terms of water and power. So this complex is called the Adaptive Management Program. We call it the AMP. It's the Adaptive Management Work Group, meets several times a year to talk about what the recommendations are to the Secretary of the Interior. But what the transition here is from a kind of a closed door policy back before 1991 to a very much a public policy discussion that anybody can show up at. So this is a very big change in pre-dam, post-dam management of the Colorado River, and getting refined as time goes on. So let's take a little look at how these changes affected the Colorado River as socio-ecosystem? And what are the consequences and implications of these changes? Well, going back to some of the basics, can we manage sand in Grand Canyon to preserve beaches and therefore conserve our $30 million a year recreational activity in Grand Canyon? Sorry. So what we have implemented through the Adaptive Management Plan and program are planned floods. Do these work? Well, yes, they're actually gradually working to help build up the sand. There are glitches here. If we end up with a lot more water up in Lake Powell than in Lake Mead, reservoir equalization can strip away these gains. But with conscientious measurement of the sediment coming in from especially the Prairie River and good monitoring, we can see that high flow events can really contribute to beach building activities. Erosion is a natural process. Over time, the beaches will erode away, but then having periodic planned floods is a way to manage the sediment resources in a mass balance kind of fashion. The sand gets dumped up to higher elevation and gradually erodes down. Big uncertainties, of course, is issues of how climate change will affect overall Colorado River flows, and therefore the amount of flow and water available for conducting these planned floods. And there's much concern going on with the construction of a pipeline on the north side of Lake Powell by the state of Utah to capture its water resources and send those over to St. George, bypassing Grand Canyon, but also reducing the amount of water in Lake Powell. These are big topics of discussion at present. So these floods, with good monitoring, we've been able to see how these floods actually work and come to some really remarkable levels of predictability for the upper canyon. Many sandbars benefit from these planned floods. You can see quite a buildup of sand surface here in a post-flood context. So good monitoring is a great tool for being able to see this. The uncertainties here are that it doesn't work at all sites. In some cases, sandbars get washed away. Mostly these are sandbars in the lower canyon, but a few in the upper canyon as well. So understanding these processes, why some of these eddies capture sand, but then those are eroded away by high flows, is still the subject of a great deal of conversation. The implications of these planned flows are that in some cases, sand accumulation at some sites with wind transport can help rebury exposed archaeological sites. So sandbar rehabilitation to improve protection of Colorado River ecosystem cultural sites is important for the Native American tribes that have affinity and that have association with the Colorado River corridor, and has been a topic of ongoing research and discussion. There are not too many sites where that can actually work because the wind direction has to be correct for the sand transport, but there are places where this can work, and so that could be important. Now, one of the big challenges with this, with the imposition of Glen Canyon Dam on the river ecosystem has been the loss of native fish. 8 native fish occurred in the Colorado River prior to Glen Canyon Dam, and half of them were lost up until fairly recently. So we lost bony-tailed chub, round-tailed chub. Razorback sucker had been considered to be extirpated from the river, meaning lost from the river corridor, but they still occurred in Lake Mead recently. And with the Park Service's enthusiastic fisheries program, we've been able to have more razorback suckers in the lower end. Perhaps that species will recover. We also lost the Colorado pike minnow, very abruptly lost the Colorado pike minnow. This is a minnow, a predaceous minnow that grew to almost 6 feet in length and up to about 60 pounds. So it was the top predator in the Colorado River system. It disappeared within 13 years of the dam, and we don't really understand why. It still exists in the upper Colorado River basin, and there has been recent discussion about how to bring it back into the ecosystem. We have remaining native fish: humpback chub, flannelmouth sucker, bluehead sucker, and speckled dace. The humpback sucker is endangered. There's great concern for these other species, but the humpback chub has garnered most of the management attention because there are enough of these things to actually study them and try to understand dam effects. So Gila Scythe this minnow grows to be about a foot long. They live for about 30 years or so, and with great conservation costs, we estimate probably about $500 million has been spent on the conservation of this and the other native fish in the Colorado River ecosystem. The Grand Canyon population of the chub is in good condition, probably more than 10,000 fish now. So that's restored. However, what happens when that, because of that success, the fish gets delisted or downlisted? What happens to fish management in that situation? Part of the reason native fish have been in decline here is because of the introduction of 20 non-native fish species, including highly predaceous bass, green sunfish, and striped bass. So as these fish have come in and occupied the clear waters that are highly productive, lots of invertebrate life produced by them, they have negatively affected a lot of the native fish populations. And increased competition as well. Many non-native minnow species in this mix. However, cold, clear water has allowed bald eagles that are passing across the landscape, especially those migrating in the late winter months, to be able to see into the water and see trout and other fish in the river and take advantage of them. So bald eagles, formerly an endangered species in our national symbol, have moved into Grand Canyon during the migration period. They don't nest there yet, but the fishing is pretty darn good in this cold, clear water for them. So that's quite a novel change, a unique predator moving into the ecosystem after 1983. Now, flood control has allowed riparian vegetation to spring up along the river, and wetland marshes along the river have really developed. There was a period of flooding in 1983 through 86 that scoured a lot of that, but wetland vegetation has really increased greatly along the Colorado River because there's no longer pre-dam floods to scour them out. Oddly, wetland vegetation responds positively to fluctuating flows. When you raise the water up and down, that's enough to water the soils each day and allow cattails, bulrushes, and other species to occupy the river corridor. In recent decades, the common reed Phragmites has taken over, and now we face the danger of a non-native Phragmites moving into the river corridor. But riparian vegetation development has been really a tremendous kind of increase in the system. My estimates show that there's actually more riparian vegetation in the river corridor now than there was in pre-dam time in bringing together both Glen Canyon and Grand Canyon. So we've got cold, clear water, marshy vegetation along the shoreline, and that's a great attractor for a lot of water birds. And so we've been able to document 60 species, almost 70 species of water birds now along the river corridor. Not too many additions or subtractions in this list. Can't see that too many of the species have disappeared, but many of them have greatly increased. Osprey regularly migrate through. Bald eagles I mentioned beforehand. So some of these are raptors, some are waders, some are divers, dabblers, quite a few shorebirds, and kingfishers. All those populations moving into this post-dam river corridor. All right, so we've got a lot of ducks in the system. Guess what? Peregrine falcons are called duck hawks, and we now have the largest breeding population of peregrine falcons of any land unit in the 48 states in Grand Canyon. This is another new top predator in the Colorado River ecosystem, formerly endangered. 90% of their biomass are waterbirds, mostly waterfowl, and the waterfowl are there because of clear water flows. Oddly and kind of wonderfully, these birds, which are the fastest animal on Earth, reaching speeds of 230 miles an hour, they spend about 30% of their time chasing swallows and swifts that feed on midges that are coming up out of the river. But those activities only account for about 3% of their diet. These changes are not without some losses. The southwestern willow flycatcher is an endangered bird, lives in riparian vegetation, typically nests over water, and it occupied tamarask-dominated riparian habitat throughout the Southwest. which also in Grand Canyon supports 24 other species of neotropical migrant birds, but and with some oddities. Tamarisk is one of the plants that moved in along the river corridor, and oddly, southwestern willow flycatchers nest preferentially in tamarisk. It's better cover for them. The Colorado River corridor is actually designated as critical habitat for this willow flycatcher. However, the willow flycatchers are now no longer breeding in the river corridor. Extensive monitoring by the Park Service and other folks have demonstrated that the several pairs of willow flycatchers that were nesting there back in the 90s are gone, and in part this is due to a very strange phenomenon that has to do with the introduction of a tamarisk leaf beetle. This is a non-native shrubby plant that has long attracted the ire of water managers because it might consume water. So USDA, Department of Agriculture, introduced a non-native leaf beetle that is very effective at killing tamarisk. Again, willow flycatchers nest in tamarisk, so the loss of the tamarisk means that willow flycatchers are nesting in the open sunlight in the desert, and the temperatures are too hot, and eventually those nests fail. So this leaf control, this biological controlled release of a beetle is reducing tamarisk cover and may well eliminate willow flycatcher as well as tamarisk. Lots of controversy there, lots of trade-offs associated with that. These are not the only non-native species in the system. I mentioned fish, but also a whole host of invertebrate species, non-native invertebrates, as well as other organisms. Of particular alarm is quagga mussel, which have now reached densities of 1,000 individuals or more per square meter on the floor of the river, and those are filtering the water, removing nutrients, and we don't really know what the effects will be on the downstream river. We don't yet have too many crayfish in the system, but these are all non-native in Arizona, and they are really dreadful predators on all kinds of aquatic life. So lots of non-native invertebrates as well as non-native fish in the system. So to summarize this, Colorado River corridor changes have involved a bunch of species that are now missing, or some of them which are making trouble. In red here are river corridor species that existed prior to the dam and may be in trouble. Some of them are endangered, like Kanab amber snail, California condor, southwestern flycatcher. These species are functioning in a kind of an imperiled way in a lot of the river corridor. Although California condor have been brought back into the system, and they're doing quite well. 80 or so birds are now flying in Grand Canyon for the first time in almost 100 years. Missing fish. Razorback sucker, as I said, is a species that is undergoing some recovery in the lower river, so that's great. But we've lost brown-tailed and bony-tailed chub, northern leopard frog, zebra-tailed lizard. The Wallapai tribe is very successful in working with the Bureau of Reclamation, has been able to bring back zebra-tailed lizard. It's a project that Grand Canyon Wildlands Council helped the tribe do, so we've got a population back in the river corridor. And species like river otter are probably extinct. We had a unique river otter species in the Colorado River that is probably now extinct. So not much chance of recovering that. Many non-native species have come into the river corridor, more than 200 plant species, quagga mussel, New Zealand mud snails, 20 non-native fish, more than a dozen non-native fish parasites, 4 non-native birds, some rodents, occasionally livestock, released pets, and we've got some diseases like pneumonia that's affecting the Grand Canyon bighorn population. So quite a few challenges here in species management. The good news is that the Colorado River can function in a restoration. This is a site at Lee's Ferry that this is all tamarisk seen in year 2000, and over time, with the help of Grand Canyon Wildlands Council and Glen Canyon National Recreation Area, we've been able to transform this landscape into a rich natural riparian habitat. It took a lot of work to remove the tamarisk vegetation, but and replant and irrigate these trees to get them started. But now it's a self-sustaining riparian ecosystem that's got the highest concentration of native species of any patch in the upper Colorado River. Other restoration activities, National Park Service at Grand Canyon undertook a project in the middle of Grand Canyon, remote site, and Grand Canyon Wildlands Council did another restoration site upstream from this, about 6 miles towards the dam, and is working on another project at the mouth of the Prairie River over the next couple of years. So this gives you a sense of what the magnitude and the trade-offs have been with the construction of Glen Canyon Dam in this remarkable ecosystem. There's so much beauty and inherent native value to what we see in Grand Canyon that it's really a world icon. You know, it's a World Heritage Site designated by the United Nations, as well as being, my take on it, is one of the best known, if not the best known, national park in the world. Glen Canyon Dam has certainly dramatically changed the Colorado River ecosystem from a warm, muddy, flood-prone river to a clear, rather steady flowing river that has much higher productivity. The Colorado River ecosystem contains highly valued relic resources, as well as novel processes and elements. All those are valued, some of them more than others. Some are of considerable concern because of what the effects of, say, introduced quagga mussel will have on the functioning of the river. The river is still changing. Every year there's a new ecological surprise that takes place that we hadn't really understood before. So even after 57 years of dam effects on this river, we're still seeing surprises on an annual basis. Adaptive ecosystem management is certainly needed to minimize species losses and to balance economic and environmental conditions and ongoing threats here. There are more politics than water in the Colorado River, and that's the nature of water supply in this arid landscape. And for us to balance economics and environmental values here really takes a societal discussion that takes place through the adaptive management program. And hats off to those of us that have been able to sit through those incredibly long meetings year after year after year to try to keep the program running. The good news is that with this kind of attention, population and habitat recovery and successes can take place. Riparian habitat can be restored. Some populations can be recovered in this system. It's not that there aren't failures, but there can be a number of successes. To learn more, if you're interested in this, get a hold of me or get a hold of the Colorado River and Grand Canyon, a comprehensive guide published by the Grand Canyon Wildlands Council and Flagstaff. All proceeds go to benefit conservation actions in Grand Canyon. So with that, we'll take any comments. Kristen can take comments and questions. And just to let you know, our next presentation will be on the 17th of August, 2 weeks from now, again at 3 p.m. on Monday. And we'll talk about springs, Grand Canyon's hidden waters. So thank you very much. This has been Larry Stevens with the biology department at the Museum of Northern Arizona. It's been a pleasure to talk with you today.
Thank you, Larry. We don't have any questions yet. I'll give people a few moments. We did have somebody commenting about the connection between the Havasupai people and the Grand Canyon. And do you have any? I mean, you mentioned the Native American people's use of the Grand Canyon and habitation there, but anything to add to that?
Well, just that, so there are 6 Native American tribes that have an active affiliation with Grand Canyon, and most of them serve on they have representatives that serve on the Adaptive Management Program meetings. The Havasupai tribe is unique in that it's embedded in Grand Canyon, and their entire culture, is really about the landscape there, about the resources associated with it. It's been my pleasure to be able to work with the tribe, doing water resource work and providing them with some information on the biodiversity of their reservation and springs there. The tribe is, quite remarkable. Locked in Grand Canyon, their access is by trail to the rim, but they have the highest percentage of native speakers of any tribe. Again, that isolation helps that, but many economic challenges and And for many years, they were restricted to a very tiny reservation that in 1975 was expanded to include rimlands. And so we expect to see the tribe perhaps shifting some of their centers of activity to include rimlands now. Wonderful, warm-hearted people that are completely overrun by tourists a lot of the time. So it's very difficult to get reservations to go in there. But they are really incredible wards of the natural environment in that landscape. So they differ from the other 5 tribes: the Hopi, the Zuni, the Wallapai, North Kaibab Paiute, and the Zuni. I said the Navajo as well. Those 5 tribes are up on the rimlands, have affiliation with the canyon in many different ways, and all play a very active role in management of the river corridor. They're consulted with any management activity that takes place there.
Thank you. Another question has come in about the crawfish species and whether they are all invasive in Arizona or whether there are any that are non-invasive.
Good question. All crayfish in Arizona are non-native. 2 species are the dominant ones that we see in our waters: the Louisiana red crayfish and the virile crayfish as an upper elevation thing. So red crayfish are one of the primary concerns. They're found in every tributary surrounding Grand Canyon, from Lake Powell down to Lake Mead, and but so far they have not invaded the river corridor itself. This means that the tributaries of the Colorado River in Grand Canyon, Tapeats Creek, Prairie River, Little Colorado River, these are pristine streams without crayfish. Some of the only remaining crayfish-free streams in the Southwest, maybe in the West. There are a total of 5 species of crayfish that are on the watch list for the Southwest. A couple of them are really bad predators. You can't kill or control crayfish. You try to poison them out and they simply walk out of the water, or they go into torpor in mud burrows and are protected from any kind of toxins or whatnot. The only way to control them is by really consistent trapping and eating them. At least they taste good. One of the few non-natives we can get some nutritional value out of.
Indeed. Yeah. Well, and you've been talking about the effect, of course, of the dam on that area. There's one person who mentioned mines, and you know, anything you want to say about any other, you know, infrastructures along the river there?
Yes, the Grand Canyon has a wonderful history of mining. It stretches back a century and a half or so. George Billingsley has written a really remarkable book on the history of mining in Grand Canyon, Pillars of Gold. And there are no active mines in Grand Canyon now, within the park boundaries. There were mines in Havasu Canyon, all through Grand Canyon. There are many mines upstream in the tributaries and along the mainstream of the Colorado River in the upper basin. And there is a great amount of concern about uranium mining through the whole landscape on the rims. Uranium mines in the upper Little Colorado River. One uranium mine created the largest uranium spill that the U.S. has seen, even though it didn't get very much attention. The Church Rock spill, I think, was in 1979, perhaps. So uranium mining in the region is a very big deal, but there are no mines in Grand Canyon that are presently active.
Well, it looks like there's no other question. Thank you very much, Larry. As several people have commented, this is very informative and useful. So much appreciated, and we look forward to the next one on August 17th.
Very good. Pleasure to speak with you all today.